Hi everybody, in this episode of Programming Algorithms we're going to look at technical architecture. So what I'm talking about here is ways of distributing software on a computer or on different computers. So what I want to talk about is two-tier architecture, which is often called client-server architecture, three-tier architecture, in-tier architecture, and in-tier with server load balancing. So what does two-tier architecture mean? Two-tier architecture means that there is a server, a computer that has a lot of the program on it, and then there's another computer, or it can be the same computer or multiple computers, let's say even, that has a program on it that helps you talk to the program on the server. So let's say we have a web server. What does that mean? What that means is somewhere in the web, let's say for my website, damiangordon.com, all my web pages are sitting on a server. Any number of you guys can visit my website through your client computers. That is to say that you have a browser like Chrome or Firefox or Internet Explorer, and your bit of software, your client software, will talk to my web server and deliver web pages for me. The same if all of our computers were hooked up to one printer and we had a printer server. There'd be software on each of our computers to talk to the printer server software. We can have two kinds of client-server architecture. We can either have a fat client, where a lot of the software, there's a lot of intelligence, a lot of processing happens on the client side, and there's some intelligence on the server side. Or we can have what's called thin client, where not a lot happens on the client's machines, and most of the processing and complexity occurs on the server side. So if we think of a smartphone and apps on a phone, the app on your phone, if it records information or stuff like that, sometimes it doesn't record the information on your phone really. It sends it off over the phone network to a server that saves the data for everybody. So all that software on the server machine is minding your app and taking care of it and pushing updates back to you and doing all that kind of stuff. Whereas your app itself is a fairly thin application. It doesn't have a lot of coding, a lot of algorithmic complexity in it. So we can have either thin or fat client architectures. With fat client, most of the processing, most of the security checking, most of the formatting, most of all that stuff happens on the client side. Whereas with thin client, the security, the middleware, the interactions, the data cleaning, the validity checks, all that happen on the server side. So that's client-server. That's one of the simplest, well, the very simplest is standalone, where the program just runs on your computer by itself. Client-server means a lot of different computers can talk to a single computer that's got a program in it, that each of the clients have a program in it that they can engage with each other. Three-tier architecture is one where there's essentially a client and server as well, but there's a different computer in between. Now, when I say a different computer, all the client, the three tiers can sit on the same computer, but conceptually, logically speaking, we see them as three different instances of a computer. So let's say I was doing Amazon or something like that. If I'm logging into Amazon from my computer, I go through a web server, application server, and that does all the web stuff. And a different computer has the database of all the Amazon books in it. So the database stores all the information. It passes that on to the application server, tier 2, which presents that as a web page. And then that pushes it over to my browser, and I can see it as a web page. So we've got a middle layer, or a middle tier, in between the client and the data. And that's a very typical style of architecture, where you've got a web front end, a web server, and then a database backend style architecture. So that's your three-tier architecture. We can also have any number of middle tiers, really. So we can have another computer sitting in between the web server and the data server that processes the data or looks at security or things like that. When applications get large, when we're thinking about things like Facebook, which has to store a lot of data, or Twitter, things like that, we need multiple layers of computing to get through to make sure that the data is safe, to make sure it's clean, to make sure it's accurate. And there's all kinds of legal implications. So sometimes we conceptually divide that up into different tiers or logical blocks. We can also have an interior architecture that has what's called server load balancing. So that is to say there's a little device in between the client and all the computers. And if it sees, let's say we want to log on to Facebook. Our typical way we go through the top of the web and application server are very slow because there's a lot of people using it at the moment. So our server load balancer will say, well, we can go down through the bottom web server and application server instead. So we can have multiple instances of an interior architecture: web server, application server, web server, application server, web server, application server. If I'm a single client, I can pick whichever route is fastest for me, whichever one isn't being used up by other clients at the same time. So we have a switch or a system that looks at which servers are busy at the moment, and it goes through the route of the least busy servers. So that's the general idea of technical architectures. Again, you'll see that over the coming years somewhat. So thanks very much. We'll see you on the next episode.